Hey boys and girls, it's Mrs. Scales. I'm here to teach you about motion and forces today. So we are starting a new unit. We are out of the human body unit and we're starting the new forces unit. So let's go ahead and get started. Alright, so the first thing we're going to talk about is what is motion. Motion obviously means that you are moving in some sense. So if you think about, like, for example, this animal here, this cheetah, it's in motion, it's moving, or the real animal would be. The way that we look and see if something has been in motion, we look to see if its distance changes. For example, if we measure the distance of the cheetah versus the trees in the background, we can tell whether or not it's been in motion. So what we need something called a reference point. A reference point is an object or place that can tell you if an object is in motion. For example, if you think about the earth and the sun, you can use the sun as a reference point to see if the earth has been in motion. And the way that we would do this is measure the distance away from the sun to the earth, and we could figure out if the earth has been in motion. So and if that distance changes, then we know that the earth has been in motion. We use a unit called meters. Meters, if you think about it, is like using feet, basically. So meters is a unit for length. It tells us how long something is. So we can, for example, say like the cheetah has been running, 10 miles or 10 meters. That's the length. That's how far it has run. All right. So if you think about motion in a mathematical sense, we always just look at the distance. So for example, this football is changing its distance. It's getting further away from this player right here, number 7. So we could say that it's in motion because its distance is changing. All right. So one of the things that we do in this unit, we figure out how fast an object travels. Like, for instance, that football or the cheetah. And the way that we do this is by looking at the speed of something. So you probably recognize these things here because these are in our everyday lives. This is a speedometer to tell you how fast a car is moving, which this one's moving really fast. This one right here, that's the speed limit sign to tell you, what your limit is on the road, so you don't get pulled over by a cop. So if you think about this, like for instance, the MPH, that stands for miles per hour, that tells you the rate or how fast we're traveling. So if you go for an hour, you have gone a distance of 80 miles. Same thing with this one here. 65 miles per hour. That's your distance and the time. So those are the two things that you need to figure out the speed. So to figure out how fast something is going, we take the distance that it travels and we divide it by the time that it takes to travel. And you just divide those two numbers out, and then that gives you the speed. And then you have to make sure that when you do a problem like this, you also carry the units with your answer, because the units make a big difference on the actual speed of, like for this one, for the person. So I want you to do this practice problem here. It says that Susie ran 15 meters in 3 seconds. What is her speed, and include the units? All right, so go ahead and pause the video and type your answer into your online notebook. All right, so the first thing you need to do is figure out the distance, which in this problem is 15 meters. And then you divide it by the time, which is 3 seconds. And so once you divide those two numbers out, you get 5 meters per second. Now, when an object is at rest, does it still have a speed? Well, yes, technically it does, and we just give that a 0 for the speed. So technically it's not in motion though, because its distance has not changed, but you can still assign a number for the speed, and you just put a 0, like for this car that's standing still, that's 0 miles per hour, and this bear is not traveling, it's just resting, so it'd be 0 meters per second. All right, so another thing we could look at for motion, we could look at something called velocity. Velocity is still your speed, but it is in a given direction. So for example, this car is traveling 25 kilometers per hour east. Whenever you add the direction, now we are given as velocity. The velocity is important because it tells you which direction it's traveling. So speed is simply how fast you're traveling. Like this one is 20 meters per second. Velocity is speed in a given direction, and this car is traveling a velocity of 20 meters per second east. So once you throw on one of those directional terms, it becomes a velocity. All right, now if you look at this graph here, we actually have two graphs. We have A and B. Which one of these lines do you think represents no motion? All right, so the right answer should be B, because it's a flat line. Flat lines represent no motion because the distance is not changing, it's staying the same. Right here, the distance is increasing, so that means the speed has increased. All right, now the next thing we're going to go over is acceleration. Acceleration is the rate at which your velocity changes. So, for example, if you are in a car and you hit the gas, you're speeding up. That's acceleration. The same thing if you hit the brake, you actually, technically it's called deceleration, but deceleration or slowing down is a type of acceleration. And then the third one, even if your speed is constant, if you change your direction and make a turn, technically you're changing your velocity because you're changing your direction. So that is a type of acceleration as well. So these are three ways that objects accelerate. Let's say you pick up this softball and you throw it, it's accelerating. When the ball lands in somebody's hands and it makes a stop to slow down, it's accelerating, technically deceleration. And then let's say you you turn the ball a different direction. Because it's going in a different direction, it's accelerating as well. So those are the three ways that we can accelerate an object. All right, and this comes to the next topic that we're going to learn about. We're going to learn about force. A force is a push or pull on something. So for example, the soccer player, he's about to kick this soccer ball. There's a force or a push that is going to be applied to the soccer ball. We can use two things to describe our force. We can use how strong it is, the strength, and the direction of it. So we can say it's going to go north. We can say it's going to go south. We can give more details to it. Now, the way that we measure the strength, we give a number in newtons. For the direction, we use an arrow to represent which way it's going. Now, that comes to the next thing we're going to discuss. We're going to discuss unbalanced versus balanced forces. So this is one of your vocab topics I want you to know. Unbalanced forces are forces that act on an object that cause it to move. So for example, let's say you're playing tug of war with a group of friends. When that rope starts to move to one side, that is an unbalanced force because one team is stronger than the other team and they are applying more force. Same thing if like you arm wrestle somebody and they start to beat you, that's an unbalanced force because they are applying more force than you. So it causes motion, it causes movement. So if you think about like this box, for example, you have two people pushing on the box. you have this bigger person who's stronger. They're pushing at about 50 newtons of force. And the smaller person, they're pushing at about 30 newtons of force. Now what we do is since the force is on the same side, we add up those two numbers and we get a total or a net force of 80 newtons. But if, let's say, these people were on two opposite sides and they were pushing towards one another, what would end up happening is their forces actually would have to be subtracted. And that's because the 30N gets canceled by the 50N. So what's left over is 20N or 20 newtons for the force. And this box will move in the direction of the strongest force. So that's unbalanced forces. One side is going to be stronger than the other, and then it's going to cause motion. It's going to cause this box to move. Now, the other type of force is called balanced forces. Balance means that it's equal on both sides. Let's say you're on a seesaw, okay? And you and your friend weigh the same amount. So that you're not like going up and down like this, you're actually just like equal. So it's balanced. With a balanced force, both of the forces are exactly the same. They cancel each other out. So what ends up happening is that there's no change in motion. The object does not move. So to go back to arm wrestling example, let's say you're arm wrestling somebody who's just as strong as you are, and you know it's like sometimes the hands go like this and they like shake, but they don't move to one side or the other. That's because you two are a balanced force. You're just as strong as one another. So it causes no like immediate motion with the hands either way. Same thing if you were playing tug of war and both teams were as equally as strong, then the rope wouldn't move to either side. It would just stay in the middle until one side gave up. All right, so what we can do, we can figure out the total amount of force or the net force. The way that you do this is if the arrows are going in the same direction like these two, you add up the two numbers because the force is being applied in the same direction. So what would be your answer here? So if you got 10 newtons, that's right. You add up those two numbers because the arrows are going in the same way. Now, if you're looking at this one here, you're probably thinking, well, I'm not really sure about this one. Remember that they're canceling each other out. So if they're canceling each other out here because they're going towards each other, then what you would do is you would subtract these two numbers. So for this one here, you will get 0 newtons. All right, now with forces, we have to talk about another type of force. And that's friction. Friction is the type of force that slows everything down. So if you're in motion, friction is the force that acts against you. Friction, for example, if you're walking across the ground, is the force that rubs against your feet. So you can see here in this picture here that when something pushes across the floor, friction acts against it, and that's what slows it down. You can also feel friction when you rub your hands together like this. Okay, we feel it as heat. I put this picture here to show you friction because I thought it was really funny. If any of you have been playing on the turf before, you've had turf burn. That is a result of friction. And this person here would get major turf burn on their face because of the friction with their face in the ground. So I want you to think of some other types of friction that you can think of. If you've ever been on ice, you know that friction is less on ice and that causes you to slip and fall. And smooth surfaces don't have as much friction. Okay, so make sure you click on the second video to watch the second part of this notes.